So I just finished talking about the Wittig reaction, but we should talk about how to generate Wittig reagents. Now, one of the great things about these is that it's possible to generate the reagent using things that we'll probably already have in our storerooms or that are easy to buy. And that is, all we really need is the halogen of the reagent that we want. So just going back to the Wittig reagent that I used in the last video, I had an ethyl group on there. Well, if I want to generate that, I just start off with the 1-bromoethane. Then I would add triphenylphosphine. That's the phosphorus with 3 benzene rings attached to it. And once I've done that, then I'll add a very strong base. So N-butyl lithium works quite well for this, and a lot of laboratories will have this available. Suffice it to say though, you need a really strong base to take off one of the protons. And we'll go through the mechanism on how these reagents are generated. And when you do this, you will make the Wittig reagent. Then you can go ahead and do your Wittig reaction. This will also generate butane in the process, right? Because that's the other reaction for when we take away one of the protons there. All right, so let's go through the mechanism for this. And what initially happens is this phosphorus does an SN2 attack on this bromine. So we'll need a leaving group on here. Usually it's bromine or some halogen that we'll use. They're widely available and not too expensive. So we have SN2 attack, typical SN2 mechanism. And then what we'll generate here is this, which is almost the Wittig reagent, but not quite, right? Next, so I've gone ahead and drawn in one of the hydrogens that's present on here. There's 2, but I only need to have 1 drawn for this. Next, we add in our really strong base, which in this case is butyl lithium. That's going to steal that hydrogen, and then those electrons will return to that carbon. That will generate my Wittig reagent. Now, this brings up an important point about Wittig reagents. Now, you have to have a proton available for you to steal from that carbon that has the leaving group on it in order to generate the Wittig reagent. So you can't do this with tertiary carbons. Well, there's actually 2 reasons you can't do this with a tertiary carbon. One of them is this first step is SN2, and so I'm not going to be able to do an SN2 on a tertiary carbon anyway, right? Because the backside is blocked by all that steric hindrance. But then the second step is to remove a proton, so one has to be available anyway. So you can generate Wittig reagents if you have a primary or a secondary carbon, no tertiary. So So you've got to have a proton on that carbon. Now, the phosphorus does help with the deprotonation because it helps stabilize this carbon species being deprotonated. Butyllithium works really well for this because you're generating something that's more stable than the butyllithium is. I've got a negative charge here that's very exposed and very concentrated. That's what makes this an amazing nucleophile. It also makes it a pretty good base, but it will come in, take this proton, and then this nucleophile, or this carbon, has a negative charge on it, just like that one, but it has that stabilizing effect of the phosphorus on there, which really helps it to be formed. So this is quite a favorable reaction. This also shows that it's really simple to generate a lot of different reagents as long as we have a good strong base, my triphenylphosphine, and some either primary or secondary halogenated reagent, such as a brominated reagent. So these are relatively common reagents that we can have in the laboratory, we can use to generate this powerful carbon nucleophile. And then that can be used to do the Wittig reaction.